Right. So it's a great pleasure to introduce you to Kyunghyun Cho, one of the inventors of neural machine translation. Kyunghyun has been a speaker at LXMLS in the last 4 years, I believe. He is an associate professor of computer science and data science at NYU, New York University, and also a CFAR associate fellow. Until recently, he was a research scientist at FAIR. Before that, he was a postdoc at the University of Montreal with Joshua Benju, and he received his PhD and master degrees from Aalto University in Finland. Thanks a lot, Kyunghyun, and the floor is yours.
Yeah, thank you. Yeah, so I mean, just like anybody else, I also recorded all these video lectures, so we'll be watching them all together. But I just wanted to say that welcome to Lisbon. This is one of the favorite parts of my summers. This year, unfortunately, I'm going to do the same thing in New York City. However, I hope you have been enjoying all these lectures. And then today I'm not going to talk much about the actual sequence generation or sequence modeling, but this lecture is going to be all about the evaluation and then how I believe, and then quite a few other people in the community believe the evaluation should change into rather than how we actually do the evaluation. I hope you enjoyed it. If you have any questions, please post it on the Zoom's QA functionality, or you can put it on the Slack as well, but I don't think I can actually go back and forth that easily. So post it on the Zoom. I'll try to look it up. It's a 7-segment video lecture. So in the middle, I'm going to stop and then try to answer any of the questions you have. So shall we start with the video recording?
Hi, everyone. I hope you're enjoying the summer school. It's unfortunate that you don't get to enjoy the summer in Lisbon, just like I'm not enjoying it either this year. But hopefully the content of the summer school has been useful enough and then full of the content that you're going to take enough time to digest and then use for your own research and development in the future. So we have learned a lot of things so far, and then one of the things that we have learned is how to build a machine learning system in order to generate a well-formed sequence where, in particular, we have focused on natural language text. So that is, we now know how to build a system that is able to learn to generate a very fluent and well-formed text simply based on data. So that's great. But then, of course, the other side is evaluation. So how do we know that those systems are creating the text that we wanted to create? And today at this lecture, I'm going to talk about that a bit and then trying to give you this sense, at least a slightest sense of what it takes to be able to design a correct algorithm for evaluating a natural language generation system. This is a joint work with the Alex Wang, my PhD student at NYU, and Michael Lewis, who is now a research scientist at Facebook AI Research in Seattle. So one side of this whole story is generation, as you may have already learned how to do so very well using a neural network. On this slide, on the left-hand side, you see an article about the dog walking startup WAG from CNN. I'll give you some time to read the text. At the start of 2018, WAG looked like tech's next big thing. In January, the founders of the dog walking startup announced they had landed a $300 million investment from SoftBank's Vision Fund, and so on and so on. Sounds reasonable, although it's quite amusing to think that there is a startup that is trying to build this business centered on the idea of walking the dog for others. On the right-hand side is another article. This one is from TechCrunch about Rowan Zeller's new startup that is purported to be Uber for dogs. And then the fact that this startup has raised $17 million in Series A round. I'll give you some time to read it. In today's competitive ecosystem of startups trying to convince consumers to execute popular apps in favor of their own, you think that the dog walking market would be the easiest to crack. Well, it's not. But at least one startup believes it has a new and clever solution, applies core offering of mobile-based recommendation engine algorithms to locate dog owners near them with the end goal of making dog walking more efficient. Sounds reasonable. Now, can you tell for each of these articles whether it was written by a human journalist or by a machine? It's not actually easy at all. I tried my best and then I couldn't really tell which one was better written or worse written. Or I couldn't even tell which one is more likely or realistic or not. I'll just give you the answer right away. The one on the left-hand side is written by Sarah Ashley O'Brien at CNN Business, while the one you saw on the right panel was written by a machine or the neural net called Grover Mega by, of course, Rowan Zellers and the colleagues. So this is amazing. Generation is amazing. And in particular, one that I want to focus a bit on today in this lecture is the open-ended text generation. In open-ended text generation, we are faced with a situation where there's no single right answer. Furthermore, the generated text may vary significantly on how detailed they are, as well as how broad the coverage is. And some of the examples of the open-ended text generation includes story generation, poem generation, all those chatbots that you hear about, lyric writing, and summarization. And I'm going to focus on summarization today. And when we think about summarization and also the open-ended text generation in general, it's not only just a rosy picture you get. It does work really nicely. However, it is imperfect as well. And in particular, summarization can be very tricky, even to say whether it is imperfect or not. So let's try to forget about the article on the left-hand side, and we're going to focus only on the right-hand side of the slide. And then on the right-hand side, we read a summary that was written by a machine. Let's read it out together. Kevin Sinfield scored his first try of the season against Castleford. Lee's Rhino scored unbeaten run against Tigers to 6 matches. Ryan Hall was sent to Lee's Rhino for first time in his career. Now, assuming that you have no idea about rugby in England, I guess so, right? England, as much as I have no idea about it, then you might say that this summary kind of looks unnatural because the sentences are not really well connected with each other, but that may just well be because I just don't have the context of what the English rugby looks like. However, you are not going to doubt whether this is a well-formed summary or not, because it does look pretty well-formed, and then you can read it, and then assuming that you have the right context, you'll be able to understand what it's saying. Now, however, let's now go back to the original article and then try to see if this summary was a good summary or not. And what you notice immediately is that this summary is actually not a great summary. So it is a very well-formed summary, but it does not summarize the content of the original article as faithfully as possible. And this kind of imperfection, and in particular, hard to perceive imperfection or hard to verify imperfection, is making the whole business of deploying or using these neural text generation systems in practice. We may end up deceiving people. We may end up building a system that's going to churn out fake news, even though our intention was all good. That's why on the other side of this whole neural text generation or the natural language generation with the neural net lies the issue of evaluation. And I'm going to talk about evaluation much more in detail, in particular with the focus on summarization. But before I do that, let's get some questions about this. And then if you have anything you want to talk about, we can actually talk about it before we delve into the details. Welcome back.
Okay, I mean, like the so that was the first segment, and then it looks like there's no other questions. I guess we can just continue with the second segment. Or actually, there is a question on the QA panel. So yeah, do please use the QA panel because I'm actually actively monitoring it. So there's a question from Richard. So I'll just read it out. How far can we reasonably include subject knowledge in evaluation frameworks currently? This is actually a great idea. So often when we think about the evaluation, we think about the very static evaluation where there is some kind of ground truth that may include some of the subject knowledge as well, and then score it against it. So in that sense, is however much you want to encode your subject knowledge, you can always do it. However, the question is that how much control you can have in encoding such and subject knowledge, and then is there a way for you to make a trade-off between the objective, let's say, knowledge and the subjective knowledge. And then in the rest of the talk, we are actually going to look at a way to do the more of the dynamic evaluation that is based on the data. And then in this particular paradigm, you can inject any kind of subject knowledge or the domain knowledge, or as well as subjective knowledge that you have that is not necessarily in agreement with the other's knowledge into this whole evaluation scheme by encoding, injecting into the data, as well as our generation or the decoding algorithm. So hopefully the rest of the talk will be able to answer this question more in detail. All right, is there any other questions? Otherwise, we're going to go on to the next video clip. But as I spoke really slowly, we're going to play it at the 1.25x the speed of usual playback.
Welcome back. I hope we had a great discussion about why we want to focus even more now than ever on evaluation, because the neural text generation has gotten so much better and then it's getting only better. So let's talk about the evaluation of summarization systems, and more so the automated version. One of the main or the dominant metric that has been used to evaluate automatic summarization systems has been Rouge, which was proposed in 2003 and 4. And then the weirdest thing is that this dominant metric has not always been, or is not widely being perceived as the best way to go. And then there are many reasons, but two key deficiencies that many people who are building these summarization systems or who have been building these summarizations agree with are, first, that the Rouge often compare against a single or a small number of references. It's not only because of the Rouge itself, but there's an issue. This is an issue stemming from the fact that the summarization is an open-ended text generation problem. And unfortunately, we cannot get as many reference summaries as we can by asking humans to write them. Now, the second deficiency is that Rouge computes the n-gram matches between the generated summary and the reference summary. By doing so, it does not distinguish between salient or important n-grams from non-salient or the non-important kind of trivial n-grams. And what it means is that the Rouge is not going to be able to weigh different n-grams based on their importance or whether they contain actual content, but Rouge is going to weigh all those n-grams equally. And by doing so, or rather in doing so, factual inconsistencies as well as many other content sensitive signals may be drowned out. And what these two key deficiencies imply is that Rouge is not the perfect metrics we want to use. However, in reality, everyone uses Rouge. So I have just picked 3 papers from the past 3 years that have claimed that they have built the state-of-the-art neural abstractive summarization systems, which is the correct claim. They did indeed do so. And then qualitatively, we do see that every time such a claim had been made, the system looked better. The summaries looked reasonably better. And then when they run some kind of human evaluation with a lot of limitations that I might actually go into later if I have time, according to human evaluation, those systems did indeed get better. Unfortunate thing is that they all claim their supremacy, or the fact that their system outperformed the existing systems based on this Rouge metric, which, as we talked about, has significant issues that almost everyone agrees with. So what is going on here? It turned out that both of these cases, or the claims, so the claim that the Rouge is not a great metric and claim that they have built a state-of-the-art summarization system according to Rouge, are not really contradicting with each other. When we say Rouge or any kind of n-gram-based metrics with reference summaries are not ideal, what we are saying is that the high overlap in n-grams against the reference summary does not equate to a better summary. And then by saying so, we are saying that we should not evaluate an automatic summarization system with an n-gram-based metric. On the other hand, people who have been claiming to build the state-of-the-art summarization system according to Rouge or any of its variant were in fact saying that they built a system that can be trained, where the system is a text generation system that can be trained with an arbitrary metric, such as an n-gram-based metric or Rouge. So weirdly so, in fact, they haven't really claimed, to be specific, that they have built a good summarization system. What they have claimed is that they were able to come up with a neural text generator that can be trained to maximize this specific metric called Rouge. So both of them can actually stand without contradicting each other. So that's perfectly fine. But in this talk, we're going to focus on the first aspect. That is, we want to build a good automated summarization system, and we want to know how good that summarization system is. In doing so, we actually do need to go back into history and then trying to see what others have already thought of and have tried. First is that the people have noticed that the intrinsic evaluation is very, very hard. So what do I mean by intrinsic evaluation in this case? I mean that we are evaluating the quality of the summary without worrying about how this summary is used or in which context this summary appears. So it's highly context independent, or is supposed to be context independent, and should only measure the intrinsic quality of a generated summary from a summarization system. Unfortunately, it's a very difficult thing because, first of all, what is the quality of summary to start with? It's almost a philosophical question. Given an article, some article, right? Now here's a summary that was written by someone or some kind of black box. Now, what do we mean by the quality of this summary? It's very difficult to even define. And it turned out trying to come up with the automated way to measure such difficult to define intrinsic evaluation is doomed to fail. Let's go back to Hao Dome and Daniel Marcoux, 2005. They participated in DUC, which has been a long-running shared task for evaluating summarization systems. And then in 2005, what they realized is that their system sometimes ranked really highly, sometimes ranked really lowly, and then only difference was which automated intrinsic evaluation metric was used. And in fact, some of the metrics were semi-automated in a sense that some parts of the evaluation procedure or the protocol involved manual labeling or the annotation. So it looks like it's really, really difficult. And this difficulty is rooted in the fact that the intrinsic evaluation is just often too ambiguous. And then this leads to high variance in scoring. And then high variance in scores does indeed lead to a noise or the extremely noisy ranking of the different systems. So looking at one of the automatic intrinsic, well, not automatic, it's a semi-automatic intrinsic evaluation metric called linguistic quality score from DUC 2005. It actually asks for the 5 questions. Is it grammatical? But do we actually know what the grammar is? And then can we actually check the grammaticality objectively easily? It's not that easy. Second question, non-redundancy. It stated that there should not be unnecessary repetition, but how do you define which kind of repetition is necessary or unnecessary? Is it more or less in the eyes of the beholders? Well, I guess ears of the beholders. Third question, there should be no dangling references. Fourth question, no sentence should contain irrelevant information. But how do you decide which one is relevant and which one is irrelevant? Fifth question, structure and coherence. A summary, a generated summary should be a coherent body of information. Coherent. Again, what does that even mean? It's very vague notions that human annotators or some kind of automatic metrics had to give an answer to. It's quite clear why intrinsic evaluation is very difficult due to its ambiguity. Furthermore, when we try to simply ask users how good a summary or any kind of text generated from the open-ended text generation system is, we notice that everyone is so different. And then this is connected to the issue with the ambiguity as well, because the intrinsic quality of summaries is going to depend heavily on individuals who are reading those summaries. And what we see last year doing evaluating the chatbot or the chit chatbot that we have built, we actually did notice that every single annotator had its own standard as well as its own variance. Some of the annotators were simply completely random. Some of the annotators were just too harsh. Some of the annotators were simply too generous. There were so many possibilities, and simply looking at the average scores or the standard deviations was not informative at all. And at the end of the day, if we could do this kind of intrinsic evaluation automatically in a perfect way, then we should be able to get nearly a perfect summarization system as well, because we're going to simply generate as many summary candidates as possible and then score each summary using this automatic intrinsic evaluation toolkit, and then choose the one that has the high score. It's just so difficult. And then that's the whole point of building or using machine learning algorithms to build such an automated summarization system. So it does tell us that it is very, very hard. My guess is that we must have at least 1 or 2 questions at this point about the intrinsic evaluation and why it is so hard for this kind of open-ended text generation, of course, summarization. So let's try to take, let's try to have discussion about the difficulty of the intrinsic evaluation before we move on to the other paradigm called extrinsic evaluation. Has the
All right, so that was another part that has passed. So there was one question by, let me just see, the Mohammed, and then I answered it on QA panel by writing down to type down the answer. But I think it was a really great question, so I'm going to just repeat it just quickly. The question is whether the reason why we don't really try to use the word embeddings in order to evaluate the quality of the generated text against the reference text. So this is in fact a good idea already from 2015. People have been looking into what if we had this word embedding, can we actually go beyond the simply comparing the surface form of the generated text against the reference text that was often written by humans. And that does work better, that does work well, because first of all, it can actually go beyond the surface form level because the similarities between two words do not have to rely on how they are written down or spelled out. Rather, they're going to be based on the continuous vectors that, that were automatically extracted from the data. And furthermore, more recently, people have to realize that we can use not only the word embedding, but more of the contextual word embedding using, for instance, BERT, in order to get even a better similarity score between two different texts. What they're going to do is they're going to look at the vectors extracted from all those words on the reference as well as the generated text. And then those vectors are all contextualized. And then they're trying to find the alignment between those two vectors. Let's say the alignment can be approximate or soft, and then try to summarize the similarity scores among those aligned pairs. So they do tend to work better, that's for sure. However, those approaches still suffer from the issue that they are not able to distinguish salient text from non-salient text. And also they cannot really let you control what is being measured and what is being evaluated. And in particular, we're going to focus on if we could come up with some kind of proxy task that we want, and then that is known to measure or to reflect what we want to measure, then we can actually have a much better control over what is being evaluated. And furthermore, we are going to see that we can in fact build an interpretable, so human interpretable evaluation metric in the rest of the lecture. And then meanwhile, there are a couple of questions here. So let's start with the first one by Ivan. So I didn't get well, what is intrinsic evaluation in this context? Could you elaborate? So this is a really interesting question because, like whenever I think about evaluation, you do hear about the intrinsic as well as the intrinsic evaluation. And of course, the line between intrinsic and extrinsic evaluation metrics is extremely fuzzy, right? But when I say intrinsic in this case, I meant that this is a quality that's inherent to a generated text, regardless of how the text is going to be used or regardless of what the audience is of this generated text. So that's what I meant by the intrinsic. So the intrinsic evaluation is difficult to define, but we're going to talk about the extrinsic evaluation in the next segment, and then that's going to make it so much clearer. So anything that is not extrinsic, we're going to consider this intrinsic for now. And then Marco has a question. In ACL 2020, there was a great focus on evaluation for NLP in general. The best paper, for instance, proposed a unit test-like approach. Do you think such an approach for a similar one can be adapted here too? Yes, indeed. So the best paper at ACL from Apple, if I remember correctly, led by the Carlos question, was on trying to claim or propose that it is not enough to come up with a single metric that is going to evaluate the quality of any kind of NLP system. In fact, that's going to be any kind of automated system. But then we need to have a list of items that we need to check before we are sure that this system is going to do what we intended it to do. So this is a bit orthogonal to the discussion today we are having, in a sense that this particular method that we're going to talk about could be one of those items in a list of the unit tests that you want to run for every new automated system. Now, the one thing that we need to be a bit careful about is that what are those unit tests? Each and every unit test cannot be just an arbitrary set of automatically generated, let's say, set of tests. Each and every one of them has to have some meaning that allows you to look into why such a test has been failed and then how you can in fact fix the issue underlying this failed unit tests. So in that sense, it's important to have those tests to be more or less interpretable as well as self-explanatory. And then the methods that we're going to look at is going to give you one particular idea how to do so. So I think we can continue on to the next segment then.
Welcome back. Hopefully our discussion has clarified anything that was unclear about the difficulty of intrinsic evaluation. Now, if intrinsic evaluation is so difficult, then is there any other thing that we can do? Of course, people have been thinking about it over decades. 3 decades ago, in 1992, Maurice et al. Proposed an interesting scheme to evaluate the quality of summarization system. Their idea was based on the reading comprehension or question answering. If you're familiar with the TOEFL, IELTS, or any kind of exam, then you notice that there's always a section called reading comprehension where you're going to be presented with a paragraph based on which you need to answer multiple questions. And often the questions are multiple choice questions so that you need to choose one particular answer out of the 4 to 5 answer candidates. Now in this setup, we can now think about evaluating how good my summarization system is by trying to generate a summary of the original paragraph that you were presented. That is, we're going to replace the original paragraph with a generated summary, and then we'll try to answer the questions based solely on this generated summary. If I can answer those questions as well as I could with the original passage, that implies that this generated summary has enough facts that are consistent with the facts in the paragraph, original paragraph, that allows me to answer these questions. And then this is the idea of extrinsic evaluation, where we are evaluating the quality of a generated summary or generated text in a certain context or under a downstream task, which was question answering in this particular case. Now, it took some time, but in 2005, more than a decade later, 2 different groups, Dora et al. And Domain and Marco, came up with an idea to use search engine instead of question answering in order to perform extrinsic evaluation of summarization system. The idea is relatively straightforward, but pretty ingenious. We start from a query that's going to be issued to our search engine or information retrieval system. And this IR system is going to retrieve a bunch of documents that are relevant, that are supposed to be relevant to the issued query from a large database of documents. And then we, as a query issuer, we are going to check whether each retrieved document is relevant or not, right? They were supposed to be relevant. That doesn't mean that all those documents are relevant. So we are going to check the actual relevance. So we're going to do the relevance. We're going to judge the relevance of each document ourselves. Now, we're going to select some random subset of these retrieved documents and then feed each one of them into our summarization system or the summarization system that we want to evaluate. After this stage, we now have a set of summaries, not the original documents. And what we're going to do is we're going to judge the relevance of each summary with respect to the original query that was issued. And now you get the idea already, right? If the relevance judgment between the original document and its summary agree with each other, then there was a good summary. And we can now look at many of those documents and pair summaries to get the degree to which this summarizer was able to maintain the information that makes the original document relevant to the query that was issued. In short, the higher the agreement on relevance, the better the summarizer is. It's a pretty good idea, so this is good. And then compared to intrinsic evaluation, this extrinsic evaluation is so much better because first, it's often much less ambiguous. You can think about comparing between chit-chat against a goal-oriented conversation. Second, extrinsic evaluation often tends to be much more easily quantifiable. In the case of the relevance judgment or the relevance prediction-based extrinsic evaluation from the previous slide, we can literally count the number of documents that we have summarized and the number of document summary pairs for which the relevance judgment agreed with each other or they stayed same. And that the proportion is going to tell you precisely the quality or the degree to which the summary maintains the information from the original document. Now, of course, there's nothing that has only the advantages. There's, of course, extrinsic evaluation also has some disadvantages. One is that we need to now prepare our annotators. For instance, in the case of the Maurice L's proposal to use the reading comprehension, we'll have to make sure that our annotators are good at answering those questions based on a long text. If they are horrible at answering, of course, their answers are not going to be trustworthy, and then the agreement rate also cannot be trusted either. The second disadvantage, which is a bit, let's say, difficult to say whether it's really a disadvantage, is that many of these downstream setups are artificial and are not natural. Think about the reading comprehension section from TOEFL. The questions and paragraphs there, paragraphs there are often good because they are excerpts from the different articles or the existing articles. However, the questions tend to be very unnatural because they were designed to test the ability of English as a second language speakers, and then they were designed to split hair essentially. And because of that, questions are unnatural. Although it's unclear whether this is truly a disadvantage in terms of evaluating the quality of the summarization systems. So because of the first two advantages and these two, let's say, more or less neutral disadvantages, personally, I prefer extrinsic evaluation, and that's the one that we're going to focus on today. Now, both extrinsic and intrinsic evaluation methodologies that we have just talked about requires you or me who are human annotators. Because we know that automatic intrinsic evaluation does not work well. That was the initial motivation why we started talking about the whole thing. We often have to resort to the manual evaluation for open-ended text generation, such as in summarization. And then this implies that we need people to do this repetitive, boring job of reading long text and then giving some arbitrary scores in the case of the extrinsic evaluation, or having to spend huge amount of effort in trying to answer questions or reading a document and determining its relevance to the original Korean, so on. This is the one unfortunate downside of the intrinsic and extrinsic evaluation.
All right, so now we should know what it means to have the extrinsic evaluation. And then there was a very nice question by Richard. I tried to answer it briefly while the video was playing. In a sense that if the evaluators need to be prepared, how can we actually tell that it's more of the preparedness of the evaluator that this evaluation method is evaluating or the measuring, but not the actual quality of the summarization system? So preparedness of the evaluator indeed is one aspect of this extrinsic evaluation methods, but the other side is that we have to be very, very careful in what are the things that we ask to these evaluators so that we can dissect out the effect or the influence from the varying levels of the preparedness. So in a sense, it all comes down to, let's say, causal inference versus capturing the spurious correlations, because there will always be a correlation between the extrinsic evaluation methods output and the preparedness or the varying degrees of the preparedness of the evaluators, in addition to the actual degrees of quality of the things that we evaluate or we try to measure the quality of. And it turned out that TOEFL is actually one of those examples where the questions can be pretty weird, but those questions are designed very carefully in a way to measure the quality of the evaluator's preparedness in some sense. So we could always design evaluation methods to explicitly in order to focus on the quality differences in the generated text while ignoring the differences in the preparedness of the evaluators. There are many different techniques to do so. We can design the questions in that particular way, or we can even use the post-hoc calibration, for instance, using many different methods from the causal inference or even from the Bayesian, let's say, probabilistic modeling as well. So extrinsic evaluation, I do personally prefer it. I do think that we as a community should move more and more toward the extrinsic evaluation and stay as far as possible away from the intrinsic evaluation. However, it does not mean that our move or the reorientation is going to solve all the existing problems. In fact, this is going to bring up a lot of issues that we haven't even expected or that we haven't planned ourselves for. But that's precisely where we need to focus our effort and then trying to solve them scientifically using many of the research methods that we have. So if there is no other question, I think that we can move on to the next part. And then finally, we can actually talk about what I'm actually preparing or proposing to do in order to evaluate these the summarization systems without having to rely on what is the inherent quality of generated text.
Now we need to think about how we can, in fact, avoid this issue of needing you to spend your effort for my research in summarizations. And then for that particular purpose, today I'm going to focus entirely on so-called factual consistency. Now, the quality of the summary, quality of any summary cannot really be summarized in a single scalar. It does include many different aspects of the goodness of such summary. So what are those aspects? Of course, there's the aspect of the fluency. So how well formed is this text? And better formed the text is, the better summary it is. What are some other aspects? Perhaps it has to not lie. Maybe what it needs to do is state only the fact that were included in the original article. What else? Maybe it needs to cover all the salient facts from the original article. If it misses certain parts of the original article, maybe it's not as good a summary as the other summary that may cover all the salient facts. And you can see that there are many different aspects to the quality of the summary. And then we are going to focus on the second aspect, that is a factual consistency. That is, does any fact contained in a generated summary agree with the facts contained in the original article? Is the fact from the generated summary consistent with the facts in the original article? So that's going to be our focus. And then we're going to say that any summary is good if it is factually consistent with the original article. So why are we focusing on factual consistency? One particular reason is that we have observed over the past couple of years that these neural text generators are amazing at generating fluent and well-formed text. However, these neural text generators were also found to be exceptionally good at lying or making up facts. So that's why we're focusing on this second aspect of the factual consistency. So let's just go back 27 or 28 years and then back to the time of Maurice et al. 1992, because this is going to be the framework, the use of QA that we're going to build our evaluation methods. So we want to check or double check that this paradigm from Maurice et al. Actually makes sense. To do so, let's look at the paragraph on the left-hand side of this slide. The steel pipe crosses windswept plains and endless miles of delicate tundra that tops the frozen ground. It weaves through crooked canyons, climbs sheer mountains, plunges over rocky cracks, makes its way through thick forests, and passes over or under hundreds of rivers and streams. The pipe is 4 feet in diameter, and up to 2 million barrels or 84 million gallons of crude oil can be pumped through it daily. And then based on this paragraph, I created 3 summaries. Summary 1, the pipe delivers 2 million barrels of crude oil across tundra. Summary 2, the 4-foot wide pipe carries 84 million gallons of crude each day. Summary 3, the 4-foot wide pipe carries 84 gallons of crude each week. Now the question is, which one of these 3 summaries is best? To do so, we're going to introduce one particular question we want to answer. And this question is, according to the second paragraph, 84 million gallons of oil can travel through the pipeline each. And now we need to decide which one of the four words follows this sentence best. Day, week, month, or year. Now, if you had paid attention, then you see that the answer to this question, once reading the original paragraph, is A, day. Now let's try to answer this very same question based only on one of these summaries. Let's forget the fact that we read this original passage. Now, had we read only the first summary candidate, the pipe delivers 2 million barrels of crude oil across tundra, then we wouldn't be able to answer this question because this summary just does not contain this fact. Had we written, oh, I'm sorry, not written, had we read the second summary candidate, that is, the 4-foot wide pipe carries 84 million gallons of crude each day, then we'll be able to answer as we answered reading the full paragraph. The answer is going to be day. If we only had access to the third summary candidate, that is, the 4-foot wide pipe carries 84 million gallons of crude each week, then our answer would have been incorrect because the answer would have been week instead of day. And then what this tells us is that by trying to answer a given question using only summary and then compare the answer to the answer you got by reading the entire original passage, now you can tell which summary was good. Or in other words, you can now tell the quality of the summary that you use in order to answer this question. And in this particular case, the best summary was the second summary. Now, this is a great idea, right? So we can probably use this idea to check the quality of any generated summary. And then thereby, after pulling the qualities estimated for all those generated summaries, we can estimate the quality of the summarization system as well. Under two conditions. First, I should be able to ask ETS to create TOEFL questions as many times as I request. Okay, I don't think ETS is going to do that for me. But let's say that the condition was satisfied somehow. The second condition is that I should be able to ask all of you to take TOEFL, especially in particular the reading comprehension section, every day for my research because I want to check how much scientific progress I'm making in terms of building new algorithm for summarization. I don't think any of you is going to do that. Maybe for fun once, but not for, I don't know, like years that I'm going to need in order to come up with a learning algorithm that builds a satisfactory summarization system. So what can we do? I think some of you already got the idea. We go all the way back to the beginning of the lecture. How did we actually start our lecture? We started our lecture by talking about how awesome these neural text generators are. The text that you generate using these neural nets these days, they look almost identical to the text written by humans. So then can we now use that for the purpose of evaluating such text? That is, can I replace both ETS and all of you with neural networks instead?
All right, so now I guess hopefully you all get the idea of where I'm getting it. And then the idea is that we want to be able to use the paradigm of extrinsic evaluation in order to tell whether a generated summary is good or the automated summarization system is good by not relying on the human evaluators, but by relying on a neural network or a group of neural networks that are able to solve a problem that we are going to use in order to tell the quality of the generated summary. So in other words, extrinsic evaluation makes so much more sense when you think about having a group of prepared evaluators, as well as a group of people who are ready to generate all those problems that are going to be solved by the evaluators using generated summary, both of which are very expensive to come by, and also that it's not easy to train people to do all those things. because it is kind of difficult to educate people. That's the whole problem of the education in general in the modern world, right? However, what we are trying to look at is that because the neural nets have been very successful at solving various problems, including reading comprehension type of questions, and also neural nets have been very successful at generating extremely fluent questions as well as the answers. We're going to combine them and then use them as the replacement of the human annotators for both evaluation and creating questions in order to evaluate or in order to measure the quality of the summarization text. So there was a question about the recommendation on the particular summarization approach to a particular problem, but that one needed a bit more details. And then my guess is that it is going to be very, very focused on a specific sector. So if you have any questions that are relatively narrowed down to your own problems, and it has a very detailed, let's say, qualifications or the conditions under which that question needs to be answered, please do use Slack, and then you can leave the question there, and then I'll try to find some time later today in order to answer them. And also, if you want to talk about it further, and then especially if you're not a student, but work at some of those startups or the companies that are not really tech-oriented too much, if you go to my homepage, there is a section called Pro Bono Office Hour. So I spend about an hour every week to talk with the people who requested to talk about their problems in machine learning and natural language processing. So do use that feature, and we'll be able to talk a bit further for about a half an hour in order to answer your questions. And I think we can now move on to the actual description of the algorithm that I put forward here.
Has the discussion convinced you that we can use neural net to implement this extrinsic evaluation, or the idea from Maurice in 1992 in this modern world to evaluate the summarization system automatically? I hope so. And then now I'm going to give you how we can do it in specific. And that's where we come up with the idea called CAX, which is a short for question answering and generation for evaluating summarization. Now this slide is the only slide where I have an equation that's going to be more or less meaningful. And it turned out this single equation actually tells us all about how to build an automated extrinsic evaluation method for evaluating summarization system. Now let's see what it computes. I'm going to just read along this sentence very slowly. And then as I do it, I want you to look into the parts of the equation that corresponds to the color of the parts of the text that I'm reading. So let's start. So the CAX computes the expected agreement between answers based on the original passage and its summary using questions generated from the summary. Does that make sense? Now, this is pretty dense, I agree, but at the same time, this is one of the most concise way to describe how we can automate the whole procedure of extrinsic evaluation. Now let's go through each of the components more carefully. This is a pipeline that consists of 3 stages. The first stage is question generation. Because we want to compute the expected agreement, we now need to look into not a single question, but multiple questions that could be created from a summary Y. And then to do so, we use a state-of-the-art neural text generator. In particular, we use BART that was fine-tuned on NewsQA, and then we built an answer conditional question generator. That is, we're going to look at a summary, and then we're going to identify some of the salient objects, such as the named entities or the noun phrases using off-the-shelf NLP toolkit. And then we're going to ask our question generator to generate a question from this summary and a desired answer. And once we train this model on any kind of QA data, that is the news QA data, then we can now use this model, which defines a distribution over all possible questions, to generate as many questions as we want. And in doing so, we use beam search with some heuristics-based filtering of the candidate questions. This heuristics turned out to be not that important, but we use it in order to make sure that we get a set of reasonably well-formed questions, which in turn gives us the way to interpret or understand what this evaluation metric does. The second component in the pipeline is question answering. So once a question is generated from this summary, we now need to have a question answering system that's going to answer this question using either the original passage X or the summary Y. And in this paper, we use the extractive question answering model, although there's absolutely no reason why we have to use extractive question answering model. As long as we have some way to compare the output from this question answering model using either the original passage or the summary, then it should be all fine. In particular, we use BERT fine-tuned on Squad 2.0 in this case. The last stage in this pipeline that defines KEX is the agreement. So how do we define the agreement, or how do we measure the agreement between the answer from the question answering model based on the original paragraph and answer by the question answering model based on the summary? And in particular, we can use, well, not particular, more specifically in our paper, we use the token level F1 score. So we just trying to look at how many words overlap between these two answers. But of course, again, let me emphasize that the any divergence measure can be used. And then that's what makes this KEX more of a framework that can be used for many different cases of evaluating open-ended text generation systems rather than only for summarization system. Now let's just do some summary of what this KEX does, or how we are going to evaluate the quality of a summary without relying on the ambiguous definition of intrinsic quality. Rather, we're going to look at how well this summary is in terms of the downstream task that is question answering. But we're going to remove the necessity of manually crafting any questions or manually answering any of those questions. We are going to use neural networks to generate questions and answer them for us. So we start with the original paragraph source, and we let some black box summarization model to generate a summary for us. And then once the summary is there, we use a question answer generation model to generate a bunch of questions. And for each generated question, we ask our question answering model to answer it either based on the original source or the summary. And we're going to compare whether they agree with each other or not. And we look at it, this agreement rate over all the questions that were generated from the question generation model. And this is KEX that we have proposed. And then this is how we're going to automate the extrinsic evaluation methods that was proposed already 3 decades ago by Maurice et al. In their paper where their abstract was written automatically by summarization system. So let's try to think of this whole framework once more. If you have any questions, feel free to ask me now. And then if you have any comments, I'm also very open to hearing about your comment. So I want us to have some kind of discussion on what this KEX is, and then whether this makes any sense to start with. And then after that, we're going to look into how we can evaluate these new evaluation methods for the particular purpose of evaluating a summarization system.
All right, so you just heard about the description of the algorithm itself. So the interesting thing is that as we move toward a more sophisticated evaluation methods, it's not just a simple, let's say, one-line comparison between the reference summary or the reference output and then the generated output, but this evaluation paradigm itself becomes a very complicated learning algorithm itself. So this is a kind of, let's say, slightly different way of thinking about the idea what should be done in terms of evaluation, because often our way of thinking about evaluation is stuck at the point of 0-1 loss, which you must have learned at the very beginning of this summer school, where we simply look at whether the generated answer is identical to the reference answer. So there's a question from Ivan. did you rescore some of the SOTA models using these new methods? How did it perform? So we haven't really rescored or re-ranked some of the SOTA models ourselves because many of those models are not available nor easy to use. That's just one of the unfortunate side effects of the field moving too fast. However, we did use the generated summaries from those state-of-the-art models in order to tell how well this proposed approach correlates with the human evaluation or the human judgment. And then that's going to be mentioned in the next segment. And then another question from Ivan is, let me see. Okay, how does the chosen models affect evaluation? We're going to see that soon enough, because I'm going to show you how well this evaluation metrics correlate with the human judgment. Of course, it becomes a bit ridiculous to talk about how this evaluation metric is better than another evaluation metric, as we talked about at the very beginning. It's not a single expected value that we compute to tell which one is better or not, but it's more like many different metrics that cover as many or as different aspects as possible about the quality. So we're going to look into it a bit later. And then another question from Daniel is, can we imagine that summaries have qualities that aren't captured by questions? Indeed, that's true. So what I just told you about is a way to capture the aspect of the factual consistency. And then, as you can imagine, the quality of any text cannot be summarized into a single quantity. It's not a one-dimensional line where all these text is sorted into. And then we can say that, ones that are further away from zero is better, ones that are close to zero are worse. It's not like that. It's a very multi-dimensional aspect. But what we're talking about here is that in this multi-dimensional space, one axis is factual consistency, and then factual consistency can be measured by using a question answering. So that's what we are talking about. And then to do so, what is the right way to automate it? So if you want to measure different aspects of the quality of the generated summary, then we may need to come up with a different, let's say, tasks that can be automated. And then I'm going to talk about it very briefly at the very end. And then the final question before we move on to the next segment is from Kyunghyun. And the question is, can you further train the QA and generator system as well at the same time like the GAN, and would it help or would it diverge? So this is a really great question. So I have focused on the aspect of the evaluation, but one of the purposes of having this kind of evaluation is to use that evaluation in order to check the progress of our advance. And then of course, one of the best way to achieve that is to in fact align the progress to maximize certain metric. But any kind of evaluation metric has an issue whenever they are being used as a main objective of development or training this kind of model. And the reason is because we must think about the generalization. And then as soon as we start using a correct metric, however, using a training set and trying to maximize it, then we inevitably run into an issue of overfitting. And then when I say overfitting as in not only in the overfitting to a training set, but also overfitting into a particular domain as well as a particular setup. So we have to be a bit careful about using this, as a part of the learning loop. So what is the right way to do that? I don't have an answer to it, but it is indeed one of the goals. And then I'm going to briefly talk about it near the end of the talk. All right, shall we then move on to the next segment? We're almost at the end of the talk, so stay tuned.
So are you convinced now that this CAX is a good way to build an automated extrinsic evaluation metric? I hope so. And at least I was completely convinced when Alex Wang, Mike Lewis, and I were able to come up with this paradigm. So, of course, it doesn't really help me trying to just tell you or trying to convince you by telling you how awesome this framework is. We need to, in fact, try to empirically evaluate this evaluation metric itself. To do so, we first need to collect data on human judgment of the factual consistency of a generated summary, which is not easy at all. no one is going to be willingly spend their time, even if they are being paid, to read the original article, which is often quite long, and then read the summary, which is often also several sentences long, to make sure that this generated summary is factually consistent with the original article. It's just a very difficult problem. And even when people are willing to do so, it's very unclear whether people can make a very good, consistent, objective decision or the assessment of the factual consistency of multi-sentence summary against a long article. So we had to come up with a way that's going to allow us to get a consistent assessment of the factual consistency of this generated summary against the original article from the humans annotators, in particular mechanical Turkers. So Alex designed this simpler task where we're going to show them, of course, the original article, but for each summary, we don't show them the full summary. We're going to show only a sentence from the summary. And then we ask them, does this sentence or is this sentence consistent factually with the original article? Now it turned out that the Turkers suddenly become much more consistent in their own answers as well as the answers across the others, with the others, yes. So we collected all this data, and then the consistency score of each summary then is going to be the aggregate of the consistency score of individual sentence. And then we consider this as gold consistency scores. So let's get into the results directly. So we use two data sets. One is CNN Daily Mail from 2015, and the other is Exxon. I'm not a big fan of either of these data sets for the summarization, but they have been used widely, and also they are one of the few data sets where we have large enough number of examples to train a strong neural text generator, which often gives us a very nice fluent summaries. So on CNN Daily Mail first, of course, we're going to look at all those n-gram-based metrics, including variance of rouge, variance of blue, as well as media. And on top of that, we're going to also look at one of the most recently proposed metric that is based on a pre-trained BERT called BERT score. And on the y-axis is the Pearson correlation coefficients against human judgment times 100. I mean, the Pearson correlation coefficient should be between -1 and 1, but we're going to show you as the number that is between -100 and 100. So first, rouge scores, which are dominant evaluation metrics for summarization or evaluating summarization systems. And what we see is that it does have the non-zero correlation. So that's the good news, but they are not as high as what we would have hoped or what we would have expected from dominant evaluation metric. Meteor, which was designed to evaluate machine translation systems, turned out to be as good as rouge scores. Blue scores, again, were designed to evaluate the machine translation systems, but it turned out, again, they work more or less similarly as rouge variance or meteor does too. And then these are all against the human gold consistency judgments that we collected using Amazon Mechanical Turk. Now, BERT score worked reasonably well, but only as well as the rouge one, which was one of the best metrics that we have tested here. One thing I want to emphasize before I show you how well KEX worked in this particular case is that all these metrics except for KEX do require the availability of reference summary that was written by a person. And then that's not always available. And then that in fact works as a pretty big hindrance into scaling up this kind of evaluation scenario or the evaluation paradigm, plan, protocol, evaluation protocol. Now, how well does KEX work even without reference summaries? It turned out that the KEX correlates so much better with human judgment than all the other metrics. So that was a good sign. So, and then, we tried it on the Exxon, which is slightly more recent, but it was created in a way that is a bit less, what is the right way to say, a bit fishy. Because what they did was that they took an article and then simply said that the first sentence of that article is the target or a good summary of the entire article or paragraph, which is true in many cases. However, sometimes once you remove the first sentence, there's just not enough information left in the paragraph to reconstruct, that is, create this summary that is the first sentence of the paragraph. That's why it's a bit tricky to use this data set alone to measure how well summarization system works, or how well this evaluation metric for summarization system works. But well, we are using it in tandem with the CNN Daily Mail, so hopefully that's fine. Now again, similarly, we start with the root variance. Again, they do correlate. It's not that they are uncorrelated with human judgment, but the correlation, the magnitude of this correlation is not high. Medial works as well as root scores, unsurprising from our based on our previous observation with CNN Daily Mail. Blue scores, we see a similar trend, but weirdly so, in this case, bird score completely failed. I don't really have a good conjecture on why this happened, and I believe this is a good kind of research topic for the future to figure out what these continuous vector-based n-gram matching metrics do, and then what kind of things they are really bad at. Now, and the KEX, of course, works or the correlates with the human judgments better than all the other metrics, although the difference is pretty small compared to the difference that we saw with CNN Daily Mail. Now, one unfortunate thing about the proposed KEX or this kind of learning-based evaluation protocol is that there are a number of knobs that we need to tune in order to get the most out of it. And in particular, in this KEX, we have 3 knobs that seem pretty important. First one is that the quality of question answering system. Second one is the quality of the question generation system. And then the third one is how many questions we need to use in order to get the score. Now, by varying these quantities and then trying to look at how well the scores we get from KEX while varying these quantities correlate with the human judgment, we have made 3 observations. First is that the quality of the question answering system does not matter that much. It does up to a certain level. However, we saw that the scores that we get from KEX are extremely robust, or extremely insensitive to the quality of the question answering system. Now, however, we saw that the correlation is going to get better, or we observe a higher correlation when the quality of question generator is high. Now, again, this is not a big difference that we're talking about. However, it was important enough for us to try to get as good a question generator as possible. The third observation, the last observation, was that the number of questions definitely matters. On CNN Daily Mail dataset, the correlation coefficients against human judgment jumps from under 45 all the way to 60 by simply increasing the number of questions we use per summary to 50 from 10. It does make sense. It's a very large space, the space of all possible questions. And then we're computing the expectation over that space. So we probably want to look at as many questions as possible, as many reasonable questions as possible. So let's look at one particular example of how it works. On the left-hand side, you see an original article, and then on the right-hand side, there is an automatically generated summary. And then now, given this summary, question generator is going to generate 1 question at a time, which is going to be answered by our question answering model twice at a time. Once with the original passage, the other time based on the summary. And then what we see is that sometimes these answers, the pair of answers, are going to agree with each other partially. Sometimes they are going to agree with each other almost perfectly. But of course, there will be other times when they are going to be completely different. And then that's when we know that the summary contains an information that is not consistent with the original article. And then by looking at many of these questions and looking at the proportion of the questions to which the answers agreed, we know how good the summary is. The proportion is precisely the quality of the summary in terms of vector consistency, of course. Now, to just sum up what KEX is, is that it is a reference list evaluation method for summarization systems. And then it does so by running extrinsic evaluation based on question answering automatically. And then how do we do that? We did it by replacing ETS and all these human annotators with neural nets. And one amazing thing about this KEX is that it is in fact interpretable by design, because all the questions that are generated by question generators are human readable, and also answers tend to be human readable. We can go directly into set of questions that were generated and answered, and we can tell why a specific summary was scored high or low. And then it allows us to inspect the aspects or the certain subset of facts in the summary that are inconsistent with the original paragraph. So that's the interpretability there. And one thing that is a bit minor, but still an important detail in my opinion, is that for this, we didn't have to do any CAC-specific data collection nor engineering. Of course, we had to train a question generator, we had to train a question answerer, but we just used a generic publicly available question answering data set in order to train those systems. We didn't have to do any kind of specialized data collection for this new evaluation method. So, well, it's time to wrap up, but the success of CACs that hopefully I have been able to convince you about, in fact, indicates that there is a change in the relationship between learning and evaluation. Up to now, we have been thinking about evaluation as relatively separate thing from the actual learning algorithm that we want to evaluate, and we almost thought that evaluation or the evaluation methods have to be static. That is, evaluation method should not change depending on how we build this evaluation methods. On the other hand, we have been changing the learning algorithm over and over. And then we've been checking our progress by using this static evaluation methods. But what we see now with this CACs, as well as a bunch of others who have come up with or put forward a similar proposal during the past 2 years, they are all listed on the presentation side. What we see is that the learning and evaluation can in fact form a virtuous cycle. So they can form a virtuous feedback loop. Better learning algorithm that allowed us to build a better text generator has been used in order to build a better evaluation methods for summarization system. And then of course, what we expect or what we need to do now is to use these better evaluation methods to improve or guide the development of a better learning algorithm. And this better learning algorithm that was guided by this better evaluation method is going to fit back into this evaluation methods, or the fed back into developing an even better evaluation method. And then this is going to go on and on, hopefully allowing us to make a better progress and allowing us to know more precisely what kind of progress is being made.
Okay, so now hopefully everyone is convinced about CACs and then your idea what is the right way to do this kind of extrinsic evaluation or the text generation, where the evaluation has always been tricky. So I mean, I don't know if you have we've been following recently, there's been a big, let's say, I wouldn't call it hype, but the excitement from the people about the OpenAI's GPT-3. And then what you notice is that it's not too difficult to find the very exciting examples there, but it's increasingly more difficult to tell how well, objectively saying, as objectively as possible, how well those generated examples are. Are they just good? Did they get lucky? Did you get lucky? Or did I get lucky? Or is it true that it's just amazing and that it's going to just work up to, let's say, 90% of what you'd always want to achieve indefinitely? So all these things make it more, so the advances and the amazing recent successes that we have seen from these neural sequence models, especially in terms of generating a very fluent, natural looking text, has brought out the necessity of spending more time and more effort in how to evaluate those systems. And hopefully this talk has been convinced you that it's an important topic, because at least for my own sake, it's been very difficult to convince my own PhD students that evaluation is very important and they should spend years on this. But yes, I think it's a really interesting topic. You've learned all about how to generate them. So let's, I hope that you'll have time to think about how to evaluate them as well. And then that actually concludes my talk. If you have any questions, you can always put it on Slack so that I can answer them over probably later today or even tomorrow. And also, if you have further questions about this work, the KEX in general, then you could email Alex Wang, who is the PhD student at NYU, and who led the whole project together with me. And yep, that's about it. So how should we go from here on, Andre?
Thanks a lot for your talk, Kyunghyun. It was really nice. I think there are no questions right now in Q&A, so I think this is it. I don't know if anyone wants to add anything.
Oh wait, hold on. There's part 7.
There is a part 7.
No, okay. So that could be an optional thing for people to watch.
Maybe
I think that's about the future direction slides, right? Yes, yes. Oh, I forgot about it. So yes, everyone, please, go check out the YouTube link. I think there will be a seventh part, and that's about the future, but nothing that actually works. So okay, yes. Oh, there is actually one question. So maybe we can just wrap it up after me answering this one question from Antonio. And then could this be applied to interpret what a model is uncertain about if several summaries are generated and used to reply in parallel? Yes, indeed. This is a good point about the interpretability. So the nice thing about this whole KEX and this framework is that when we see that the score is certain number, we can actually tell what are the questions that were not answered correctly based on the generated summary, so that the score was not 100%. And then those questions and then answers are all natural language. So we can in fact look at them, and then we can tell what were the effects that are associated with these questions to which the answer was different from the answer that was generated based on the full paragraph. So that's a great point. So it is much more interpretable than many of the existing evaluation metrics. And then of course, KEX is a bit slow because you need to train a question answering model, you need to train a question generation model. But once everything is trained, it's relatively fast to run it using GPUs because everything can be parallelized. And then I guess we can wrap it up then. Thanks for the invitation again. Yes, hopefully next year we will be able to meet in person.
I hope so.
Yeah.
All right. Thanks a lot.
Bye-bye.
Okay. Thanks.